Hello students and viewers, this is ETETA from Morogoro, Tanzania. My name is teacher Ramadhani Kideghesho, teaching chemistry. Welcome to the series of our lesson from ETETA TV. In this lesson, I will show you the correct way of attempting the questions of chemical kinetics, equilibrium, and energetics. I will start to answer the question number 12 from CSEE Necta 2020. The question says, question number 12A says, ammonia gas is manufactured by reacting nitrogen gas with hydrogen gas in the presence of catalyst. Write the balanced chemical equation for the reaction and explain the role played by the catalyst in this reaction. So here there are two questions: to write the balanced chemical equation, then to explain the role played by the catalyst in this reaction. This is the question number 12A. The question number 12B says, the following figure show the reaction path between sodium hydroxide and hydrochloric acid. So this one here, this path. So sodium hydroxide, hydrochloric acid, these are reactant. The product is sodium chloride and water. So the reaction path for sodium hydroxide and hydrochloric acid. Given a reason, classify the reaction based on the energetics and predict the effect of cooling the system while increasing pressure at the same time. So here also there are two questions. The first question is to classify the reaction based on the energetics. And the second question here is to predict the effect of cooling the system while increasing pressure at the same time. So I will start to attempt the question number 12A. Here is to write the balanced chemical equation. The balanced chemical equation is this. Nitrogen react with 3 hydrogen. 1 mole of nitrogen react with 3 moles of hydrogen gas to obtain 2 moles of ammonia. So this is the balanced chemical equation. The second is to explain the role played by catalyst. So the role played by the catalyst in the reaction is to ensure that the reaction is fast enough for equilibrium to be set up within the very short time. So the role of catalyst is to ensure that the reaction goes fast, the reaction complete at a very short time. In the absence of catalyst, the reaction is so slow that virtually no reaction happens in any sensible time. So this is the role played by any catalyst in the reaction. And for this reaction here, this is the Haber process. The catalyst which is used in this reaction is iron. So the role played by iron is to ensure that the reaction goes fast. After this, the question number 12B. The answer is, since the energy of reactant is higher than that of product. The question says, since the energy of reactant is higher than that of product, show that the energy is released to the surrounding. For this matter, the reaction is endothermic. So the reaction is endothermic because the energy of reactant is higher than that of product from the reaction path. The pressure works if the reacting substances are in gaseous state. The pressure works if the reacting substances are in gaseous state. But for this reaction, there is no gaseous substance. Since there is no gaseous substance, for this reaction, the pressure does not have any effect. So the effect of cooling the system favors the forward reaction as the reaction is endothermic. So the reaction is endothermic. So cooling the system, the forward reaction will be favored. That is, the reactant change to product. Sorry, this reaction here is exothermic. The reaction is exothermic. As the reaction is exothermic, so the cooling the system, favor the forward reaction. The reactant change to product. So this is the effect of pressure and the temperature at the same time. Pressure does not have any effect because the reacting substance does not involve the gaseous substances. But for the side of cooling, if you lower the temperature, the forward reaction will be favored as the reaction is exothermic and the reactant will change to product. After that, I'm going to solve the question number 6 of CSEE Necta 2019. Question number 6 of CSEE Necta 2019. The question says, in the industrial preparation of sulfur trioxide, equilibrium is established between sulfur dioxide and oxygen gas as follows. This is the chemical reaction. 2 moles of sulfur dioxide react with 1 mole of oxygen to obtain 2 moles of sulfur trioxide. And the change of heat here is negative 24.9 kilojoule per mole. So the question number 6A, Roman 1 says, is the forward reaction an endothermic or exothermic process? Give reason. So here you need to show if the reaction is endothermic or exothermic. If it is endothermic, you have to give the reason, or if it is exothermic, you have to give a reason. And question number 6A, Roman 2 says, how will you adjust the temperature and pressure to maximize the proportion of the product at equilibrium? So this is the question number 6A. The question number 6B, Roman 1 says, why is it unfavorable to work with very high pressure and very low temperature in the contact process? Roman 2 says, what catalyst is used to speed up the rate of formation of sulfur trioxide before attaining equilibrium? So these are 2 questions from question number 6B. I will start to answer the question number 6A. The forward reaction is exothermic. As the question asks if the reaction is exothermic or endothermic. So the reaction is exothermic. Why? This is because the negative sign from the heat change shows that the heat is released to the surrounding during the reaction process. So if the heat is released to the surrounding, this means that the reaction is exothermic. Roman 2, in order to maximize the proportion of product, the temperature should be lowered and the pressure should be increased. As we have seen here, that the reaction is exothermic. The exothermic release the heat to the surrounding. For that case, lowering the temperature will favor, the forward reaction will be favored and the product will be produced in high proportion. But also, for the case of pressure, let's return back to the chemical equation here. The chemical equation shows sulfur dioxide, 2 moles of sulfur dioxide react with 1 mole of oxygen gas to obtain 2 moles of sulfur trioxide. Here from this balanced chemical equation here, you have, we compare the number of moles of reactant and product. From the reactant, we have sulfur dioxide and sulfur and oxygen, sulfur dioxide and oxygen. So the number of moles for sulfur dioxide and oxygen is 3. 2 plus 1 is 3. But for the side of sulfur trioxide, which is a product, the number of moles is 2. So you have 3 moles of reactant and 2 moles of product. Now, For the case of pressure, the pressure will look, the pressure goes to the side where the number of moles is less. So for this case, if you increase the pressure, the forward reaction will be favored. The forward reaction will be favored because the number of moles of product is less than that of product, 2, 3. So for that case, in order to maximize the proportion of product, the temperature should be lowered and the pressure should be increased. Now, the answer for question number 6b is, Roman 1, very high pressure and very low temperature is unfavorable for this reaction. Why? This is because it slows down the rate of the reaction. As we have seen that this reaction works under low temperature and high pressure. Low temperature and high pressure. But if the temperature is very low and if the temperature is very low and the pressure is very high, it is unfavorable because the catalyst can't work under very low temperature and very high pressure. So it slows down the rate of reaction. The temperature compromise for this reaction is 450 degrees centigrade, while the pressure is 1 atmospheric pressure. So the pressure is 1 atmospheric pressure, while the temperature is 450 degrees centigrade. This is what is required. So if it is lower than 450 degrees centigrade, the reaction is unfavorable. It is unfavorable for that reaction. But if the pressure is higher than 1 atmospheric pressure, the reaction will be unfavorable. The condition will be unfavorable for that reaction. Now, the question number 6b, Roman 2. The answer for question number 6b, Roman 2. The catalyst used to speed up the rate of formation of sulfur trioxide is vanadium 5 oxide. So here it is vanadium 5 oxide which is used as a catalyst for this reaction. Now, the question number 8 from CSEE Necta 2018. The question says, the following equation show the reaction between hydrogen and iodine gas to form hydrogen iodide gas. 1 mole of hydrogen react with 1 mole of iodine to obtain 2 moles of hydrogen iodide. Change of pressure is negative 800 kilojoule per mole. Given the reason, explain what would happen to the position of equilibrium if the temperature is lowered, the hydrogen iodide gas is pumped into the system. So here there is Roman 1 and Roman 2. In case the temperature is lowered, what will happen? Or if the hydrogen iodide gas is pumped into the system, what will be happen? Now the answer for this question, question number 6. Question number 80b, Roman 1, if the temperature is lowered, forward reaction will be favored. Why? This is because the reaction is exothermic, as we have seen that there is a negative sign from the heat change. So if the temperature is decreased or is lowered, the forward reaction will be lowered and the product will be produced in high. But for question number 8b, Roman 2, if the hydrogen iodide is pumped to the system, the concentration of product increase. So the concentration of product will be higher than that of reactant. For that case, in order to attain equilibrium, backward reaction will be favored. So for the case of adding hydrogen iodide, if it is added from the system to the system, the backward reaction will be favored to make a reaction to attain equilibrium. Thank you for listening. Thank you for watching this video. You were with me, teacher Ramadhani Kideghesho. Thank you very much.